I'm going to continue to talk about data types and basic operations in R, and in particular in this video I'm going to talk about subsetting objects in R. So there are a couple of different operators that you can use to extract subsets of R objects. There's the single square bracket, the double square bracket, which we saw in the previous video, and there's the dollar sign. So the basic kind of principles to remember here is that the single square bracket always returns an object of the same class as the original. So if you subset a vector, you're going to get back a vector. If you subset a list, you're going to get back a list. Anytime you used the single bracket operator to subset an object, you'll get an object of the same class back. Furthermore, the single bracket operator can be used to select more than one element of an object, with one exception that we'll get to later. The double bracket operator is used to extract elements of a list or a data frame. It can only be used to extract a single element of that object, either the list or the data frame, and the class of the returned object will not necessarily be a list or a data frame. So the idea with the double bracket operator is that, because remember that lists can hold things that are of many different classes. They don't all have to be the same. So the first element might be a numeric vector, the second element might be a data frame, the third element might be a complex vector, etc. And so when you use the double bracket operator to extract an element of a list, the object that comes back may not be a list. It may be an object of a totally different class. So that's what the double bracket operator is useful for. The dollar sign is used to extract elements of a list, again, of a list or a data frame that have a name. So objects can have names, and one of the reasons you use names in an object is so that you can reference elements of that object by the different names. And otherwise, the semantics of the dollar sign are similar to the double bracket in the sense that when you use the dollar sign to extract an element of an object, it may or may not be of the same class as the original object. So here's the first example, a very simple character vector called x, and I'm going to use the single bracket operator to extract the first element. So here, what I get back is another character vector with the single element a in it. If I try to extract the second element of x, what I get returned back to me is a character vector with the element b in it. I can also extract a sequence of elements. So if I want to get the first four elements of x, I can construct the sequence 1 through 4, and then I get a, b, c, c. So in these three examples here, what I've done is I subset the vector x using a numeric index. So the numeric index is 1, 2, or the sequence 1 through 4. Another type of index that you can use is a logical index. So in this next example here, I'm going to subset the vector x, and I only want all the elements that are greater than the letter a. Right? So it might seem strange to you that I'm using the greater than sign with letters instead of numbers, but there is a lexicographical ordering to the letters, and all the letters that are greater than A are letters like B, C, D, E, etc. So what I get returned to me is a character vector that only contains the letters that are greater than A. So here I got B, C, C, and D. The other thing I can do is I can create a logical vector, which I call U, which is just it's a true or false vector which tells me which elements of the vector x are greater than a. So if I print out u here, I can see that the first element is equal to a, so it's not greater than a. And then the next four are greater than a, but then the last element is equal to a, so again that's false. And so I can subset the vector x with this u vector, and then I get out all the elements that are greater than a. So there are two types of indices that I used here. The first type was the numeric index, and the second type was the logical index. Matrices can be subsetted in kind of the way that you would expect. So the first index is going to be the row index, and the second index is going to be the column index. And we can use numbers for this too. So for example, if x is a matrix, it's a 2 by 3 matrix with the numbers 1 through 6 in it. If I take x with the bracket 1, 2, that gives me the first row, second column, and so that's going to be the number 3. And then the second row, first column is going to be the number 2. You don't have to always specify both indices when subsetting a matrix. So for example, if I say x bracket 1, comma, and then blank for the second index, that notation indicates that I want the first row of the matrix, in which case This is a vector 1, 3, 5. If I wanted the second column of the matrix, I could just leave the first index blank and say x bracket and then comma 2. That gives me the second column, which is 3, 4. So by default, when a single element of a matrix is retrieved, is returned a vector of length 1 rather than a 1 by 1 matrix. So remember I said that before, the single square bracket operator always returns an object that's the same class. So the one thing that sometimes is a little bit unexpected is that if I subset out a single element of a matrix, I don't get back a matrix. What I get back is just a vector with that number in it. So if I say x1, 2, that gives me the first row, second column of the matrix. That's just the number 3, and what I get back is a number 3, not a 1 by 1 matrix with the number 3 in it. This is usually what you want, although sometimes it can cause problems. And so you can turn off this default behavior by adding an extra argument to the subsetting operation, which is called drop. And the idea is that by default, drop is equal to true, and it drops the dimension. And so rather than getting a 2-dimensional object back, you typically get a 1-dimensional object back. However, if you want to preserve the dimensions of the object, you can say drop equal to false, and when I subset out the first row, second column, what I get back is a 1 by 1 matrix with the element 3 in it. Now, also, when you subset a single column or a single row, by default you don't get a matrix back. So, for example, if I subset out the first row here, you might think that, well, what should be returned is really a 1 by 3 matrix where there's 1 row and 3 columns, and the elements are 1, 3, 5. Well, that's not actually what you get back. What you get back is a vector with the elements 1, 3, 5. Usually, this is what you want, and it's okay. But if it's not, then you can always set the drop equal to false argument when you subset the matrix, and then you get a 1 by 3 matrix with the elements 1, 3, and 5 in it.